Okay, 6.3 key features of quadratic relations. We're going to go over what a quadratic is, what it looks like, and yeah, the key features of it. There's going to be lots of definitions here, okay? And then we'll do a visual after. So the vertex is the point at which the parabola changes direction. So what this means is that it's either decreasing, boom, hits a vertex and then increases, or is increasing, boom, hits a vertex and then it decreases. Okay, the max or min point is the greatest or least y value on the graph, okay, or the y value of the vertex. And we'll see this, but if you have a vertex in the form x comma y, this number right here, the y value, is the max or min. Okay, the axis of symmetry is the vertical line that passes through the vertex. Okay, the equation of the axis of symmetry is x equals, and then we have p, some number. Okay, where p is the x coordinate or the x value. Let's call it value. Let's be consistent with this one. Okay, so if we have the axis of symmetry, this here, the x value, that's going to be the axis of symmetry. This is going to be the max min. Okay, and on the graph, it's that vertical line where the parabola is symmetric. Okay, x-intercepts, these are the x coordinates of the points at where the parabola crosses the x-axis. So as a note, if the coefficient of the squared term, so like say like x squared, is positive, what this means is that we have like a happy face, right? Think positive, think happy. The parabola opens up, and then therefore it has a minimum, because it's going down and then up. Whereas if the coefficient of the squared term is negative, okay, think sad face, negative, right? The parabola opens down, and therefore this point right here is going to be called a maximum. Okay, and as a recall, the graph of a quadratic relation again is called a parabola. Okay, so example 1, label the parabola below based on these definitions. Okay, so taking a look, the 0 of a parabola is where it crosses the x-axis. Okay, so let's take a look at the x-axis, which is here, and it crosses here and here. So this is a 0, and then this is also a 0. Okay, the axis of symmetry is the line that divides the parabola into two equal halves. So we have this, it's already marked with this dotted line. So this arrow is pointing, and this is called the axis of symmetry. Okay, the vertex is where the parabola is at its min or max value, max or min value. Okay, so this clearly is our turnaround point. This is our vertex here. So we go all the way down, all the way up, right? This is our vertex. And you know what? We'll underline this. This is our vertex here. Right? That's the minimum value. And the y-intercept is where our parabola crosses the y-axis. So if we look on the y-axis, we locate it here. Okay? So this is the y-intercept. Okay, now let's answer a couple questions about this. What are the coordinates of the vertex? So here's the vertex. The coordinate is 3, negative 10. It's positive 3, negative 10. The quadratic opens up, right? It looks like a happy face. Therefore, the vertex is, this one's a minimum. The equation of the axis of symmetry. So what we want to do is we want to first locate the axis of symmetry. So it's x equals p, right? The p is 3 in this case. So this equation of this vertical line is x equals 3. Okay, the y-intercept is here, it's -6, and the zeros are -2 and looks like 8. Okay, example 2, fill in the table below. So we're going to do all of these characteristics about one graph at a time. Okay, so here's the parabola graph. We need to locate its vertex. So 2, -4. The axis of symmetry is the 2, right? It's the x value. So x equals 2. The zeros are 0 and 4. So we can put x equals 0, 4. Direction of opening is up, and it has a minimum. See how that asks it together in the same box because those two go together. Okay, and then the y-intercept is 0 because we have 0, 0. Okay, next one. Let's do green. Okay, the vertex here is located at -3, 4. The axis of symmetry is -3. The zeros are -5 and -1. This one opens down because it looks like a sad face, which tells us that it has a maximum. And the y-intercept, we have to just locate it. It looks like -4 there. So 0, -4. Okay, last one. First, we're going to start with the vertex, which is located here as 3, 4. The axis of symmetry is that x value, which is 3. And the zeros, well, there's none. We look at the x-axis, there's no zeros. And that's okay. It can still exist. It looks like a happy face, so the direction of opening is up, and therefore it has a minimum. And then we have y-intercept. So let's scroll back up. Let's go approximately 11. 0, 11. Okay, if the graph isn't too clear, then I would also accept maybe 10 and 12, but it looks like 11. Okay, example 3. The shape of a bridge can be modeled by this quadratic relation. Okay, so we're going to complete the table of values from -5 to 3 and then plot these points. So for the first 3, I'm going to go ahead and show you how to sub this in. So we have 25 minus x squared. 25 minus -4 squared. 25 minus -3 squared. Okay, 25 minus -2 squared. And you keep going down this entire column for all of these points. Okay, so 25 minus 25 is 0. 25 minus, well, like -4 squared is 16. I get 9. 25 minus 9, I get 16. 25 minus 4, I get 21. 25 minus 1, I get 24. 25, 24. 21, 16, 9, and then 0. Okay, so taking these points and plotting them on the graph, let's do this in green. Let's go x, 0 and 25. And then we go down to 24. And we go down to 21. And we go down to 16. And 9. And 0. There we go. Okay, so because we're talking about a bridge, I'm not actually going to go through the x-axis or put arrows on this, because in my head I'm like, okay, this is the ground, right? Like the x would be the ground, and it wouldn't go through the ground. It would just be a bridge above the ground. Okay, and that's how you plot points. Remember to label your relation. Okay, x would essentially be the width of the bridge, and then y would be the height of the bridge. Okay, I inserted the chart for C. We're going to go ahead and identify the x-intercepts. Okay, so I get -5 and 5. We can also identify them on the chart because they are the ones where like the y equals 0. Okay, the y-intercept, if we scroll back up, is definitely 25. Okay, and on the chart, this is where x equals 0. So the y-intercept is 25. Okay, the vertex is 0, 25. Always list that as an ordered pair. X and y-intercepts we can just sometimes list. Okay, max or min, this is definitely going to be a max because it opens down. And the equation of the axis of symmetry. Okay, looking at the graph, we're going to go down. It's symmetric about like x equals 0. The other way we can tell this is from the vertex, the x coordinate, so x equals 0.